Hello, ladies and gentlemen. Are you looking for a concise summary of the properties, structure, process, and applications of carbon nanotubes? Then you come to the right place. Now, I bet you're wondering what carbon nanotubes are. Well, they are allotropes of carbon with, yes, you guessed it, a cylindrical nanostructure. In this video, I will talk about properties of carbon nanotube, how strong it is, how much heat it can take, and its electrical conductivity. We will also learn the structure of the carbon nanotube and its forms like single-walled nanotube and multi-walled nanotube. Lastly, we will have a quick talk about its procedure and applications. Now, as much as I want to get to the properties already, we'll need to discuss the structures first. So, structures. As I mentioned a while ago, there are two types of carbon nanotubes, the single-walled and the multi-walled. For single-walled carbon nanotubes, they are generally closer to 1 nanometer in diameter. Single-walled nanotubes has two types, the zigzag structure and the armchair structure. Theoretically, the armchair should have a higher tensile strength than the zigzag. And for the multi-walled, it consists of multiple layers similar to the Russian doll. Their properties are similar to the single-walled, however, they are more resistant to chemicals. Finally, we have reached the properties. Carbon nanotubes are one of the strongest materials by nature. It has a Young's modulus of around 270 to 950 gigapascals and a tensile strength of 11 to 63 gigapascals. Basically, it's stronger than steel. Carbon nanotubes are also good semiconductors. They're classified as moderate semiconductors. Also, many articles claim that it's also intrinsically a superconductor. Carbon nanotubes are also expected to be very good thermal conductors along the tube, exhibiting a property known as ballistic conduction, but good insulators laterally to the tube's axis. So, as we did a while ago, we discussed the structure and the properties. Now, for the process, that's a difficult thing for there's not much information about it. But all there is that the information on how it looks like, materials needed, and setup. So this is what usually the output would look like. This is a carbon nanotube forest. To create these, you need a smooth surface with a thin layer of catalyst, a special mix of gases full of carbon atoms, and lastly, a furnace for heating like an oven. Now I know what you're thinking. It's going to be expensive and very difficult to produce. After all, it is a rare material, and the materials needed are also expensive. But the benefits of carbon nanotubes exceeds that cost. Congratulations, you made it to the applications part. Now this is my favorite part because you actually talk about real life applications of carbon nanotubes and even the potential. Now here we have many examples for the applications like bicycle frames, batteries, sensors, nano radios, car hoods, tennis racket additives, fishing rods, carbon nanotube sponges, and artificial muscles. Now, I don't know about you, but that was a very long list, and that wasn't even one fourth of the list I've actually thought of. This just proves that carbon nanotubes has a lot of applications due to its beneficial properties. Now, I don't know about you, but I can't wait for a future where carbon nanotubes is very rare and cheap. Now, I know we'll all just have to be patient about this, but soon. I hope you learned something from this video about the properties, the structure, the applications, the sort of process. Thank you for your time. I had fun doing this.